We know that changing into the shape is because of the law of refraction can be explained quantitatively. Here I have shown a red color line that shows the normal to these two different medium. One is the water and here is air. So this is the object into the air and this object is into the water. So here if you see, this is the normal, right? So air, this shape, this one of the shape of the object basically bends towards the normal, right? Light ray basically is bending, the object is bending towards the normal. If you see here, so here the basically what is happening here at this point, where this medium is denser and this is the rare. So when light ray basically enter from rare to denser, it bends toward the normal. So a light ray is entering into the denser medium and because of that it is bending towards the normal. This line, vertical line, red color. So here you can see it like this one, and similarly for at this point you can see here. So this is the point only by which the object seems to bend. This but point again is that shape is changing, right? And the fact is explained no doubt from the Snell's law, angle and the law of refraction, right? Here we know that the refractive index is defined by the speed of light and with the help of speed of light in any medium. Basically refractive index is the ratio of the speed of light in two different medium. One is the air and second is of any denser medium. We know that n is equal to 1 for the air. The refractive index of the air is 1. It means speed of light in vacuum and speed of light in air is almost same. C is equal to V, V is equal to C. It means n is equal to 1. But in case of water, we know the refractive index is 1.33. So it means the speed of light into the water medium will be different. And by using the same formula, n is equal to C upon V, where C is the speed of light, that is 3 into 10 raised power 8 meter per second. N is equal to 1.33, so one can find out the speed of light in water medium is 2.25 into 10 raised power 8 meter per second. I have just used here the Einstein formula for the relativistic length. If I use this V, 2.25 into 10 raised power 8 meter per second, and L naught is equal to 1 meter, that is 100 centimeter. So I found that L is equal to 0.66 meter, or you can say 66 centimeter. Here the purpose is not to put the value of V into the Einstein relativistic length formula. The point is only about the speed of light in the medium, that is water, and into the air, that is n is equal to 1. So in the relativistic length, which is the concept of Einstein theory of relativity, we use this particular formula for the length contraction. L is equal to L naught square root 1 minus V square C square. From that one can find out the variation into the dimension, right, according to the relative motion between the two objects, where the two objects are corresponding to the two different frames. So L naught is the proper length, L is the apparent length to the observer, V is the speed of the rod into the frame, and C is the speed of light. So by using this formula one can find out the change into the dimension if the relative motion is along the x-axis, y-axis or z-axis. So in that particular dimension one can observe the change. It means by using the length contraction concept of Einstein theory of relativity, we are just basically focusing on the change into the shape. Right, so change can occur along the x-axis, y-axis or z-axis as I told earlier. Because of the relative motion along the x-axis, y-axis or z-axis. The point is only that change in shape of the object because of refractive index. Relativistic length you have seen. In that also, because of the relative motion, right, that we change into the shape we observe, change into the shape of the object we observe. So in this particular case here, all the objects are stationary, but in the relativity we know that all the objects are in motion. So there is relative motion between the object, they are not stationary, not at rest. But the important point is in both the cases, that is the light ray. So light basically play the role in both the situations, both the places. In the relativistic length where we observe the length contraction, and into this particular observation where we see the change into the shape, bending of the object, and that can be explained with the help of Snell's law. So in both the cases the point is only this one, that shape is changing and light is common. So light is playing their role, and because of that we are observing change into this shape. The question is there any relationship between this effect